All right. So we've done navigation through the nav mesh. But what if we need to move something that's not attached to the nav mesh, right? What if we've got a plane flying this through the sky, or a helicopter, or a dragon, or something? Um, that's not going to use a nav mesh. So we're going to set that up at this point. We're going to handle that through, we're going to do a new script. We're going to actually make this, well, this is state machine. We can put it in here. So I'm just going to add this to the state machine folder. We're going to do a new, let's do a new, that's fine. We'll just hit a mono behavior. It's fine. We're going to call this, let's just call this dragon state. Um, sounds cooler. And then we're going to do just going to do them now. Create another. These aren't going to be mono behaviors. We'll make those changes in a bit. So then we'll need a dragon. Who it's thinking? Dragon state controller. And we're only going to have one state within this for right now. Obviously, you could add more at another time. But we're just going to do dragon patrolling. Alright, so dragon state's going to be set up very similar to a robot state. We're going to save ourselves some time because of that, and we're going to open up our robot state because it's going to use similar parts to this. So we're going to grab, we're just going to grab all of this. We'll just grab all this. Alright, and then let's open up our dragon state. So remember, it's a public abstract class, which means it's not a mono behavior. We're going to delete all of these because we don't need this as well. This is not going to be robot state controller. This is going to be dragon state controller. This will be dragon state, dragon state, and we'll call this DSC, 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 and DSC. Everything else stays. We can save that. That just makes it quick and easy. Alright, now let's go to our dragon state controller. I think we're good on all of that. Let's go ahead and we need our public dragon state, which is our current state. We want a public, let's do game objects. Oops. Actually, we'll do this as an array. So we'll set this up as an array because it's not going to change. And these will be the navigation points, right? These are going to be all over the sky. So we'll do dragon nav points. We're going to want a reference to our dragon game object. dragon. Let's set up, in this one, let's set up a float for dragonfly speed and a float dragon, that's not how you spell float, float dragon rotation speed, so this will be how quickly it changes directions. We're also going to, because we're similar to what we've done previously, we need to set it for sure. We're going to set a float for checking at nav point, distance. So we're going to set this to 2 for now. So this is going to be checking to see if the dragon is within 2 meters of that nav point, and if it is, then it's going to actually go ahead and switch. And I think that's good for now. As we've done before, let's actually add in our public void set state, right? We need to know what state we're in. This will be dragon state. We'll just call it dragon state. Make sure you get your capitals in the correct order. If current state is not null, right? We want to make sure we're checking to see if it's null. Then current state is going to go through our on state exit. Alright, first we exit, then we switch the state, so current state becomes the dragon state. And as long as current state, once again, is not null, we're going to do current state on state enter, right? So we exit, we enter the new, we switch states, and then we run the on state enter of that. In our update, this is where we're going to do current state check transitions first. Right, we're always going to check a transition before we do current state out. All right. And we want, so at start, we're going to do set state new dragon patrolling this, which will set up dragon patrolling in a few, so that'll type that in. Great. All right, and then we're going to add in, we're going to get our, we need to know what nav point number they're at. So we actually need to add in a variable for that. Let's see, let's make it an integer. I think that's fine. Yeah, actually makes sense to be an integer. So public integer, and we want dragon nav point number. And do we need a counter? Do we need to count? Let's see. I think we're okay with that. So let's do Let's create a public transform. This is going to spit back out a transform. Not from transform. Let's get nav next nav point next nav point. And so we'll do the dragon nav point number is going to be equal to the current dragon nav point number plus 1. And then we're going to do this percent dragon points length. And what this does is it just auto loops it. And so once it's kind of checking the percentage of the length of it, and once it gets to the end, it just is going to go and start back over. So it's just going to auto loop between all these. You could set them up to be random, but I want it to just kind of be cycling kind of constantly through the area. And then we'll return dragon nav points, and we're going to get it related to the dragon nav point number. That one, transform. So again, the transform of whatever that next dragon nav point is. All right. And then we're going to also set up, this will come into our patrolling. We're going to set up a public Boolean, a Boolean, check if in range of nav point. Transform nav point. And for this one, we're going to get our current nav point. So let's set up, we need to know what our current nav point is. So let's set up let's set up one for that. And let's just have it be a transform. Public transform current nav point. So with that, what we'll do is we're going to say that the current nav point is equal to dragon nav points dragon nav point number, which we'll have stored in the get next nav point, which we just did. Dot transform. That gives us that, and then as long as current nav point is not null, we're going to get the distance if vector 3 dot distance from the dragon transform position to the current, it's going to run off the edge, we'll jump down the line, the current nav point position is less than the at nav point distance, right? So we're checking to see if we become in range of that next nav point. If we are, we're going to return true. And if we are not, we're going to return false. If it falls all the way through, we're going to return false. Okay. That should set us up for everything we need here. Dragon patrolling is going to get taken care of in a minute, so we'll save this. And we'll do dragon patrolling. And we need to go ahead and make sure that this is not a mono behavior. We want this to be our dragon state because it is grabbing its information from the dragon's state. And so because that, we need to, as we've done before, we want to we can delete all this, public override void on state enter. Let's, when we enter the state of this, let's give ourselves a variable up here. We'll just call it public transform destination. Not from, man. Form, transform destination. So let's do on our override. We're going to set destination. Destination is equal to dragon state controller dot get next. No, not dragon state controller. Haha. DSC. Hold on, I need to set that up. Just a moment, please. Hold please. We want to have public dragon patrolling dragon state controller DSC base DSC. Okay. Oh, nope, not that. Just getting brackets. Okay, that takes care of that. Now we have access to our DSC. So when we enter patrolling, we're going to get our next nav point, run that function, and then we're going to tell the dragon, so DSC dragon game object dot transform dot look at destination. So we want it to, at our start, go ahead and look at that destination. And then we're going to set up, I'm just going to put it in between at the end here, and then we'll add it in between. Public override void on state exits. We don't need anything else there because we're not planning on exiting that state. So then we need our, we'll put this in between these, public override void check transitions. Leave that there for the moment because we will not be actually changing states in this one. All right, and then public override void act. All right, so if destination is null, destination is null, or DSC check if in range of nav point destination. I need one more of those before I do that. So we're checking to see if it's null, if the destination is null, which it should not be because we're going to be setting that at the start, but if it happens to be, or if we become in range of the destinations, right? So this is going to be true or true. Then we're going to say destination equals DSC get next nav point. And we're going to do DSC dragon nav point count. Let's see. Do we need a counter? I didn't think we used that over there. Let's go back. State. We don't need a counter. So if that's the case, we're just going to be okay with that. Find out and see what happens. Else, so if that is, so if it is null, or if it's not null, and we're out of there, we're going to, so now basically this is our movement. So DSC dragon transform translate, and I'm going to drop this down a line so it stays. We're going to do vector 3 forward times DSC dragon fly speed times time dot delta time. So we're going to move it over time. And then we're going to get our direction. Vector 3 direction is destination position minus dragon, DSC dragon game object transform position. Okay, let's drop. It mostly is there. Let's just slide this over a little bit. That makes it legible there. And then we're going to rotate. So we're going to do quaternion rotation equals quaternion look rotation direction. And then we're going to use a slurp to do our rotation over time. So it's not just going to be an instantaneous change. So it'll just kind of constantly change. So DSC transform rotation. That is too many. Rotation equals quaternion slurp. DSC transform rotation DSC. I'm going to drop this down. Stop. Drop this down so it's easier to see. Come on. Stop giving me helpful hints. DSC dragon rotation speed times time dot delta time. All right, so that is then going to be our movement, our flying, and our rotating. So as it gets there, it's going to kind of make this nice calm rotations. Okay, let's save this. And I think that should do it. We're going to, here in our, let's create a new game object. We're going to just call this dragon paths, just kind of like we've done before. We're going to do create empty within it, and we'll call this destination 1. And let's just go ahead and duplicate this. Let's do 5. That sounds great. Destination 2, destination 3. These don't have to be numbered this way. We're just going to, so we know what we're doing. 5. Okay. So we're going to set destination 1. Let's set it over here. That looks good enough. Destination 2. Maybe up here. Destination 3. Let's just kind of stick it over on this side. 3. Actually, we can kind of have this do like a long zoom over here. And a destination 5. Let's just have it come over this way. Okay. Now, let's do our dragon. Our dragon is going to be a 3D object. Let's just make it a sphere. We'll just call it dragon. Onto our dragon, we're going to add our dragon state controller, right? In our dragon nav points, we're going to click, with this selected, we want to hit our lock so that it locks it so we don't move off. Now we can highlight our destinations and drag and drop them into the drag nav points so it fills them in automatically. Let's give it a fly speed of, I don't know, let's say 10, a rotation speed of 30. This is stuff we can play with. Its starting nav point number is 0. That makes sense. Current nav point we will set. And let's put our dragon over here. Maybe not so high. Let's start them lower. Good enough. Let's make it larger. Because it's going to be, it's a dragon, right? It's that chunky fat dragon from the Dungeons and Dragons movie. Okay. Let's go ahead and save the scene. And let's hit play. And see if everything works as we expect it to work. It is not working as we expect it to work. Okay. I did get our right nav point. Should be going there. Should be current nav point. Should be destination 2. We're not there yet. Okay, let's see what's going on. Dragon state controller. We are doing patrolling, so we should start patrolling. We are updating action, transitions, patrolling, actions. Let's see here. Those are right. This should all be right. Let's see, we had an error. Let's figure out. Oh, huh. We should probably assign the dragon to the dragon. That is always helpful. Save. Play this again. There our dragon goes. So it's going. It's coming back. I think our rotation speed's a little bit too fast. That's okay. And now, oh, there it comes back. So we are once again, so we're just constantly moving back and forth between all of these states, or all these locations, right? So we're literally patrolling a very set path. Okay, let's pause that. Let's go ahead and change our rotation speed down to 10. I'm going to actually see what this looks like. Play. It's going to do a first snap because it goes to that first location. And now we're coming up to it. See, we're still a little fast on that rotation. So let's do a rotation. Let's try one. What is that going to do? There we go. That is much better. Get that nice, slow rotation speed. We could probably even drop this down actually to like a 0.5. See what that'll do. That is much smoother. And so once again with that code, right, for a patrol, nope, Dragon State Controller, this code here, this is basically allowing it to loop. So we're finding the percentage of it, and then once it comes to the end, it just goes back around. And we're just going to constantly cycle through these. One thing that you will want to check, like this one here, right? It is gotten so close, or it's rotating at such a speed that it's not actually getting close to that nav point. So this would go to maybe 3. Would end up fixing it. We'd have to actually change that. And all this comes into playing of rotation speeds and then the distances from that. Let's see. Let's change this to 0.75. Some of these, once again, just takes a little trial and error. There we go. And now we're not getting looked into that spot. We can look at the dragon blimp as it moves throughout the play space. Alright. Now we'll just wait till it comes back. Just make sure it makes the full first loop. There we go. All right. So this is how you would implement a state machine um, into handling non-floor based movement. Once again, we can't use a nav mesh in the sky, so we're able to do it through um, translates and through the slurp to do our rotations. So for those of you that are doing some stuff that would be in this air, this hopefully will be very helpful for you. Any questions, let me know.